Properties of logs. Since logs and exponentials of the same base are inverse functions of each other, they undo each other. This is a symbology here. So if the function here, f of x, is equal to x to the a to the x power, then its inverse here is the log base a of x. They undo each other. And this is symbology showing the inverse. Think of it this way: if your function of one function is x squared, the function that would undo it would be the square root of x. So the square root of x squared would just be x. Think of it that way. Except we're doing it with exponentials and logs. Okay. Now remember, logs ask what is the exponent, and here we have a raised to the log base a of x, a raised to the log base of what is the exponent of x, x. So these undo each other. That exponent and the log undo each other. And by the same token here, log base a of something raised a to the x, what is the exponent here? They undo each other, and the result is x, the inverse of it. So here we have log 2 raised to the log base 2. These are the same base here. They undo each other, and the answer is 5. Here we have log base 3 of something raised 3 to the 7th power. Base 3, you have another base there. They undo each other with the exponent. Properties of logarithms, condensed and expanded. Here we have the log base a of the product of m times n can be expanded out here to log base a of m plus the log base a of n. And this is the quotient here of log base a of m over n. You see it's log base a of m minus log base a of n. And here we have log base a of m raised to the r power, and which is the same thing as r times log base a of m. The properties of log, these properties are based on the rules of exponents. Since log, the resulting of logs is the exponents here, equal to exponents. Using log properties, write the expression as a sum or difference of the log. Expand this out. So you want to expand this out by just using the properties of logs here. In the beginning, you see you have a quotient. So you expand it out. That's a quotient of 2 logs. So you start out here. They rewrote the c in the denominator with a fractional exponent here, c raised to the 2/3 power. The fraction part being the 3 there. Using the second property here, we have a quotient of logs. We have the log of a quotient is equal to log base m minus log base n. So you can rewrite this one as the difference between 2 logs here. Okay. Then you can break each one of these up. In this case here, we have a product. So you can break that up as log base m plus something in this form, plus log base n. Like this here. Minus log base c raised to the 2/3 power. And if we can go even further with it, we have a power here. So can we write that power? So we end up with, so we have log base, log of m to the r is r log m. So we write this, pull this out, and pull this out here. So now when we look at this again, we can do this problem here by simply taking the log of one value and manipulating it this way. So we have the log of A plus 4 times the log of B plus 2/3 minus 2/3 the log of C. Now we go back the other way, condense it down. Here we have a quotient. Here we also have here product rule. So we take care of what's each individual piece here. You can rewrite this in terms of the exponent. So this becomes log base 3 of x to the x squared. You have log of y to the 1/2 power. Okay. Here we have that quotient. So notice this is the quotient of logs here. So we can rewrite that. The log of a quotient. And we're done with that. These are more properties of logs. If two values are equal, then the logs of the values are equal. If the logs of the values are equal, then the two values are equal here. This one says if you have an equation, you can take the log of both sides and the equality still holds. This one says if you have an equation and each side has a log of the same base, you know that stuff that you take in the logs of is equal. So here we have log base 2 of 8. So what is the exponent that will give me 2 to the 8? 3. 2 to the 3rd power is 8. What is the exponent that will give me 16? 2 to the what will give me 16? 4. What is the exponent that will give me 2 to the 10th power? What's that going to be? There is an answer to this, and it must be more than 3 but less than 4. We can't do this in our head. Let's put equal to x and solve for x. So set it equal to x here. Okay. Then we can put it into exponential form here. And then we can take the log of both sides. This is equal. You can take the log of both sides. We took the log of both sides here. Okay. Here we can use that power rule and pull the x down and divide by. And that's what x is equal to. Log base 10 divided by log of 2 is approximately 3.32, and that's what we would expect. It's more than 3 but less than 4. Okay. Now notice the format of what we got here for our answer. Notice the original problem there. There's a little pattern in that. And there's our answer there. Check by putting it into your calculator. So that 2.3.32 is rounded, so it won't be exact. It won't be exact. If you generalize the process we just did, we come up with the change of base formula here. Okay, the base you can change can be any base, so generally we want to change To base, we can use our calculator. That would either be 10, base 10 or base e. Here's the log button. That's equal to base e. Notice here they in the formula they have the same base. So as long as they got the same base there. And base e and base 10 are built into the calculator. So those what you would change it to. And this one here we're going to use to change the base formula in the calculator to approximate the algorithm around your answer to 3 decimal places. So we have log base 3 of 16. What's the result there? Which is literally asking 3 to what power will give me 16. So 3 squared is 9 and 3 to the third is 27. So it'll be something between 2 and 3. Using the change the base formula, this is what we get here. And you put that into the calculator, you end up with 2.524. And that finishes our presentation.